Welcome to Simplified Learning, and today we are going to see some multiple choice questions along with their explanation regarding the topic rotating biological contactors, that is RBC, and the subject is going to be wastewater engineering. So let's move to the first question. The question in front of us is, what is the primary function of RBC, that is rotating biological contactor? It is not chemical neutralization, neither it is physical filtration, nor it is disinfection. RBC carry out biological treatment of water. Alright, they are designed for biological treatment of wastewater, where microorganisms break down or degrade or decompose organic pollutant into simpler constituents such as CO2 is there, methane gas is there, and other simple nutrients. Alright, question next. What are the materials are the disc in RBC are typically made of? They are not made of metal, nor glass, nor wood. They are made of plastic or fiber, and specifically the disc are going to be rough in nature so that microorganism and the biofilm can adhere to the plastic disc. That's why they are made up of plastic, not metal or glass or wood. Alright. Because rough plastic will be providing a suitable surface for the microbial growth. Alright. Next question. Why do the discs in RBC need to be periodically emerge from wastewater? Alright. If you look at the working of RBC, they are consisting of several discs which are submerged in wastewater up to 40%. Alright. And the disc will be rotating continuously so that they will be having a cycle of submergence in wastewater, and let's say this is wastewater level, and exposure to atmosphere. When they are exposed to atmosphere, they will be having exposure to oxygen, and the disc, when it is in submergence in the wastewater, it will be exposed to organic matter. Alright. Therefore, when the disc is emerging from wastewater, it will be exposed to atmosphere and it will allow microbial exposure to air. Alright. Periodic emergence from wastewater allows microorganism to access air, which is necessary for the metabolism. Okay. Specifically, aerobic bacteria are going to need the O2 levels maintained. Then what role do microorganisms play in RBC? They consume organic pollutant. Okay. Since we are talking RBC as secondary treatment, which is biological treatment, then microorganisms are going to play a crucial role, which is consumption of organic pollutant, that is breaking down of organic matter. Okay. They do not act as filter, or addition of nutrition is not their work, or heavy metal removal is not their role. The consumption of organic matter which is present in wastewater is the function of microorganisms in RBC. Okay. They break down the organic pollutant. Then how oxygen is transferred to microorganisms in RBC? Through chemical additive, no. Through aeration pump or aeration unit, it is not provided over there. Through sunlight, no. Since we are allowing the disc to rotate, it is getting partially exposed to atmosphere. Partial exposure is with atmosphere, and submergence to wastewater. Okay, these are the two cycles the microorganisms, or let's say the disc of RBC is going to experience. Okay, through the rotating motion of disc, oxygen is transferred to the microorganisms in RBC. What ensures the continuous interaction of microbial layers with wastewater in RBC? It is the slow rotation of disc. Okay. High rotation of disc is not preferred. The RPMs are kept as low as 1 to 10 RPM. Periodic disc replacement, no, we don't do that. The discs are going to be constant in the RBC unit. Chemical additive, no. Okay. The continuous interaction of microbial layers with wastewater in RBC is ensured by slow rotation of disc. Okay, slow rotation ensures continuous interaction of microbe with wastewater. High speed rotation is not going to allow that interaction. Disc replacement is done only in case of breakage or some damage to the disc. Otherwise, we continue with the same disc throughout the service life. Then what is the primary goal of exposing the microbial layer to air in RBC. When we are saying that we are exposing the disc or let's say microbial layer or biofilm to RBC, we are talking about oxygen transfer. Okay, always remember two cycles: exposure to atmosphere, that is exposure to oxygen, and submergence in wastewater. When we are saying that exposure to atmosphere is taking place, we are talking about oxygen transfer, and when the disc is submerged, or let's say when the cycle is going on and the disc is getting submerged into the wastewater, it is adhering itself with the organic matter that the microorganisms are going to require to break down. Okay, the primary goal is to facilitate oxygen transfer, not to dehydrate the microbes, nor to increase the temperature, not to remove the pollutants directly. Direct removal of pollutant is not possible in RBC. Then which factor primarily influences the BOD removal efficiency in RBC? It is not disc material, not ambient temperature, nor color. It is kind of a silly option given over here. Okay, hydraulic loading rate is going to play the crucial role in the BOD removal efficiency, because hydraulic loading rate HLR is the volume of wastewater treated per unit area of the disc per unit time. Okay, it is going to primarily influence what will be the efficiency of RBC in removal of BOD. Then how does the rotational speed of disc in RBC affect in the microbial activity? See, higher speed are not going to allow a proper interaction of let's say air with microorganisms or wastewater submergence and microbial attachment with the disc when the speeds are high. Alright, lower speed are not going to be a optimal solution. Okay, because they are not going to properly work because of the time taken. The detention time over there is going to be very high, which is not economical or efficient. Then rotational speed has no effect. No, actually rotational speed has an effect, which is optimal speed. When we are keeping the RPM up in the range of 1 to 10 RPM, then the speeds are going to optimize the system by enhancing the oxygen transfer and proper attachment of microbial matter, that is organic matter, onto the disc itself. Okay, see, optimal rotational speed enhance oxygen transfer, promoting microbial activity and efficient wastewater treatment. Okay, there other options are not going to help in any way in microbial activity. Alright, we just saw this point. What is the typical range of rotational speed for disc in RBC system? It is 1 to 10 RPM. 1 to 2 RPM is going to be very low. 20 to 30, that is 10 to 30 RPM is going to be very high. Okay, the optimum range is 1 to 10 RPM. This is the sweet spot. Then in an RBC system, what is the consequences of excessive biomass growth on the disc? See, when let's say we are looking at a disc and biomass has totally covered the disc, then what will happen? The bacteria which is on the inside layer of the biofilm are not going to have that exposure to oxygen. Okay, atmospheric exposure is going to be absent for the bacteria which are on the inside layer of the disc or the biofilm. Okay, that's why reduced oxygen transfer efficiency is the effect of excessive biomass growth on the disc. Okay, so what happens when excessive biomass is there? Whenever a disc is loaded with that biofilm which is too old, then after some time, because of the rotation, some motion is given there, so this biofilm gets sloughed off. Okay, sloughing or slough off, it has the meaning of it is going to fall down. Okay, it is going to wash down inside the wastewater chamber. All right, and the disc is going to be clean again. Then again that exposure cycle and the submergence cycle will be taking place. Again that biofilm will grow, and from thin biofilm to thick biofilm it will be having its journey. Then again it is going to slough off. Okay, whatever the excess biofilm is there, it is going to fall off into the wastewater chamber. Okay, it has nothing to do with increased hydraulic loading rate or nothing with increased microbial activity or effluent quality. Okay, what is the common method of controlling the thickness of biofilm on the RBC. See, one thing that can happen is sloughing. Otherwise, we can have periodic backwashing in case the biofilm is strictly and properly adhered to the disc, that it is not falling off automatically by sloughing. Then we can have periodic backwashing. All right. Then why it is important to maintain a balance between aerobic and anaerobic zone in the biofilm on the RBC disc? See, in order to optimize the degradation of organic pollutant by aerobic and anaerobic bacteria as well, we will be needing the balance between aerobic and anaerobic zones. Okay. Which parameter is critical in designing RBC system to ensure effective treatment of high strength industrial wastewater? Okay. Color of the disc, ambient temperature and type of disc material do not play any role in that. Surface area to volume ratio will be playing the critical role in designing the RBC system to ensure effective treatment of high strength industrial wastewater. In addition to this, RPM is also going to play the critical role. All right. What effect does low influent wastewater temperature have on the performance of an RBC system? Obviously, low influent wastewater is going to lead towards decreased microbial activity. Okay, available organic matter and available microorganism growth is going to diminish when we are having low influent wastewater. That's why decrease in microbial activity is the correct answer here. Okay, low influent wastewater temperature decrease microbial activity through slowing down the biological treatment processes. In an RBC system, what is the primary reason for using multiple stages of rotating disc? See, when we are saying multiple stages of rotating disc, we are talking about one chamber with rotating disc, then another chamber will be there with rotating disc. Okay, and why we are doing that? See, stage 1 purification, or let's say stage 1 treatment will be taking place over here in chamber number 1. Then this influent which was in stage 1 will be acting as influent for stage 2. Okay, effluent from stage 1 will be acting as influent for stage 2, and again treatment will take place over here, and after that we can have stage 3 or stage 4, and this will be providing sequential treatment and improved effluent quality. Okay, having multiple layers, or let's say multiple stages of a treatment unit in a wastewater treatment system is going to improve the effluent quality. All right, it doesn't increase the system appeal. It is not going to reduce the overall cost. Obviously, it is going to increase the cost. All right, to minimize the energy consumption, no, it is actually going to increase the energy consumption. Okay, overall cost is going to increase, energy consumption will be increasing, but we are having the improved effluent quality for the wastewater which is being fed to RBC system. Last question, I think. How does the presence of toxic substance in wastewater affect the performance of an RBC system? See, whenever we are saying a toxic substance is there, then it will be hindering the microbial activity. It will be putting some barrier on the microbial activity. So we do not want any toxic substance in the wastewater. Okay, it is not going to increase microbial activity, nor it is going to cause any growth of biofilm, nor it is going to improve the quality of the effluent. Okay, the thing that it is going to do is to affect the microbial activity, and thereby the wastewater effluent that we will be delivering or we will be retrieving after the treatment, after it is being treated in RBC, is going to be poor. So that's it for the video. I will see you in next one. Till then, take care. Bye bye.